I said everything gonna be alright. I said everything will be alright.
Good day, wherever you're listening from, and welcome to Indoor Air Quality Radio, IAQ Radio, on Friday, June 24, 2016. Episode 419 is being broadcast live from our Studio C in the Keys Rocks, Pennsylvania. My name is Cliff Zlotnick, known as the Z-Man. John, you got to have faith, our show engineer is at the controls in Studio E, and today my co-host, Radio Joe Hughes, will be phoning in from a course he's teaching at Seven Springs Resort in Champion, Pennsylvania. Today's segments include the IAQ Radio Trivia Question, an interview with our two guests, Bill Spohn and Nate Adams. And remember, I write and post a blog after each show. Check it out at the website, www.IAQradio.com. We could not do the show without our sponsors, especially our marquee sponsors. John Don Products, where restoration and abatement contractors shop. Visit them at their website, jondon.com. That's jondon.com.
CleanFacts, the #1 information source for cleaning and restoration professionals. Check them out at cleanfacts.com.
IAQ.net and Healthy Indoors Magazine, a free online digital magazine for industry professionals and consumers. Subscriptions are available at IAQ.net.
And Particles Plus. They are engineers and manufacturers of feature-rich particle counters, air quality monitoring instrumentation, and vacuum pump technology. ParticlesPlus.com. Count on us.
Please be sure to thank our sponsors for their support of IAQ Radio when you inquire about their services and products. You can also download the show by going to the website, www.IAQradio.com, and following the link that says Go to the Show, and the show is available through iTunes. Don't forget, you can obtain your ABIHCM points, IICRC, continuing education credits, or ACAC renewal credits by emailing Radio Joe and requesting a quiz. Radio Joe's email is joe.use@IAQtraining.com. Last but not least, please visit the IAQ Radio Training Institute website for the most current dates for the training you trust at IAQtraining.com. Now for today's IAQ Radio Trivia Question. Win a cool prize by outcompeting fellow IAQ Radio listeners and being the first person to correctly answer the IAQ Radio Trivia Question each week. Submitting your answer is easy. Either email it to czlotnick@cs.com, or if you're listening to the show live, you can text in the answer via your computer. Congratulations! John Fassler, clear result, Fort Collins, Colorado, for the correct answer to our last IAQ Radio Trivia Question. The IAQ Radio Trivia Question for Friday, June 24, 2016 has been sponsored by Ideas, the solution chemistry company, creating unique solutions to odor removal, surface cleaning, and decontamination problems. Now for this week's IAQ Radio Trivia Question. The blower door, as we know it today, is rooted in a technology first used in Sweden in 1977, where it was actually a blower window. Name the Swedish researcher who brought the idea to the United States and Princeton University in 1979. Today we have two guests. Our first guest is Bill Spohn. He's a professional engineer and president and CEO of TruTech Tools Limited. He has designed, marketed, and sold a wide array of test and measurement products in the last 25 years. Bill was the design engineering manager at Backrack for 10 years and HVAC product manager at Testo, Inc. for 10 years. Since 2009, he has managed and is now president, CEO, and majority owner of TruTech Tools Limited. He regularly presents technically complex topics to a wide range of audiences on the applications of testing and measurement instrumentation in building science, weatherization, and HVACR. He has worked on many industry technical committees and holds 3 U.S. patents in instrumentation design. He also consults in instrumentation design development and application, along with expert witness work on HVAC equipment, heat exchangers, carbon monoxide, and related issues. I think we have some intro music for Bill. Our second guest is Nate Adams, who is a modern-day pioneer in the home performance industry. His career started in outside sales for a fiberglass insulation manufacturer. He then started an energy-awarding retrofit insulation contracting business in 2009. Growing frustrated with the reality that all too often he was not truly solving the problems he was called to solve, and the unsustainable treadmill of small, unfulfilling jobs that is typically the life of an insulation contractor. So searching for a better way, Nate has developed a sales process to sell the large, complicated home performance jobs typically required to solve homeowner problems at their root. These jobs typically involve air sealing, insulation, and new HVAC equipment, and often result in large IAQ improvements. Nate blogged throughout this painful transition on the Energy Smart blog, and his work was picked up by the Journal of Light Construction, where he frequently writes the energy column as well as he writes for other publications. He has spoken at industry conferences, most recently about using energy modeling to sell larger jobs. This journey has led Nate to advocate for measured results in home performance industry via his One Knob blog. I think we have some intro music for Nate. All right. Well, thank you, gentlemen, for joining us this afternoon. I suspect we have you both with us.
Yes.
Okay. Well, let's start with Bill. Bill, if I was someone aspiring to work in home performance, what would be the basic and primary equipment requirements that I would need? What does the equipment do? And what would be the price range for the different tools?
Well, first, thanks for inviting me to participate on the show, Cliff, Mr. Z-Man.
You're very welcome. You're very welcome. We're glad to have you.
Great. So the primary tools, you can actually find a lot of these. There's actually national standards that have been written that will help you align with processes and procedures to do the work correctly. One of the primary tools is the blower door, which in fact was part of the trivia quiz today, which makes an awful lot of sense. Thank you for that insight. So a blower door is used to check for air leakage inside and out, between the inside and the outside of a building shell. In home performance or building performance, those tests are done to evaluate where those leakage points might be, how much leakage there is. And those products typically cost around a little bit less than $3,000 to get a complete blower door system such that you could evaluate a building shell. One of the important things to remember is that a lot of this, or I'd say all this work needs to be done with some understanding of building science, a process we call house as a system, which has become very popular, well understood, and almost a methodology created by people like the Building Performance Institute over the years. Another type of equipment would be the thermal imager, which detects differences in heat patterns. There's all kinds of variety available now. You can even get a pretty decent thermal imager for $249 a module that plugs into your phone. And then, of course, you get higher quality, better reporting, a little bit more ruggedness as you go up in price with a thermal imager. And what a thermal imager allows you to do is see those areas where heat is leaking into or out of different areas inside the building structure to better understand the home's performance.
Okay. With all this equipment, how important is the skill of the user? I mean, does the equipment do it all, or is it really the skill of the user?
there's actually still a lot left to the skill of the user. It's the interpretation of information. Good diagnostic equipment provides you with good information, but you have to overlay that information upon the situation that you're in. You really have to have sort of a mind that works inside the walls, if you will. And if you have that gift or ability, that's a huge asset in terms of understanding things like energy flow, heat flow, air flow inside. And a lot of times that can come through innate knowledge. Notice innate has the word Nate in it, and he's my co-guest here today.
Okay.
And it can also come through exposure and experience. It can come through training and just picking up those details. By doing a lot of tests, will give you that kind of detail and knowledge.
Well, thank you, Nate. Let's move over to you. I want to get some background on the type of work that you do and so on and so forth. Can you tell the listeners what is home performance?
If you're looking to ask a big question, that's one. It's kind of like, what is medicine?
Okay.
But essentially, home performance is making a house perform to its best ability from both a comfort perspective and a health perspective, as well as making it last longer because you have fewer moisture issues, and making it more efficient. So if you do home performance well, you get all four of those simultaneously.
And what are some factors that commonly affect home performance?
Actually, I have what I call the 5 priorities of home performance. And the first one is reducing air leakage. The second one is reducing air leakage. The third one is reducing air leakage. And then we worry about insulation levels, and finally the right HVAC that's specified, installed, and commissioned properly.
Okay. Tell the listeners what an energy audit is.
Well, this is slightly tricky because there's a bunch of different ways to look at an energy audit, from a simplistic, basically, checklist, where you just use a clipboard and you go through and you check off a bunch of things. I don't really consider that an energy audit. And in fact, most energy audits that would be gotten through, say, a utility program, I don't really view as complete, because usually they give a long list of things to do to a homeowner, but they are not prioritized by whatever the homeowner wants to solve, or what the house needs, or what the budget is. And without those pieces of information, it's very difficult for a homeowner to make a good decision as to what the house needs to solve the problems that they came to the energy auditor with.
Okay. What could some benefits be of an energy audit?
It's mostly understanding. I say that there's really 3 phases to going through the energy audit process. So you start with awareness for the consumers. So like in the first stage of the energy audits that Energy Smart does, we educate the client about building science, and then we run a blower door. And those are increasing their awareness of how their house works. The next piece is understanding. So we want to present them plans and help them to understand why the different pieces of the puzzle are important and which things are most likely to solve the problems that they asked us to solve. And then the third piece of it is action. So if the understanding is good enough, that client is much more likely to execute a project that is likely to have results, as opposed to just lighting fire to a big pile of money.
Gotcha. Is there a price range for an energy audit?
Oh, absolutely. Depending on what you're looking at, many utility programs have a no-cost audit, which I'm not particularly a fan of because it ends up goofing up the market. A clipboard audit may be $100 or $200, and the energy audits, or what we call the comprehensive planning process, for my company usually are somewhere between $750 and $1,500.
Gotcha. Okay. Well, I know that in the northern part of the United States, when winter time comes, oftentimes people have an issue with something called an ice dam. Could you tell listeners what an ice dam is?
Oh, certainly. It's pretty simple what's actually happening. So when you have snow on your roof, if there's any heat coming out of the house and into the attic that can melt that snow, it unfreezes a layer of snow underneath it all. That water flows into the gutter where it's now cold again, so it refreezes. And then that ice ends up filling up the gutter and starting to fill up the roof slope itself. And behind that ice, once it gets to where it's above the house again, you get a puddle of water. And that puddle of water can, over time, if it gets deep enough, it can penetrate the house, and it pretty routinely will get walls or ceilings wet and can cause all kinds of other problems.
I think that there's some, common things that you can get at a hardware store. You have these lines which are supposed to melt the, electrical lines that are supposed to melt water that would be in the gutters. Sometimes you have these electrical strips that you can run up and down, the roof line and so on and so forth. Do those things work?
Depends what your definition of work is. So I find them to be very inelegant solutions. What you're doing is throwing energy at a problem where the root problem of that problem is leaking energy in the first place. So you're really paying twice for it. And gotcha. I just don't find it to be the best thing. There are some occasions, say you have a great deal of roof area flowing into a short amount of gutter, which I've seen. So there's 1,000 square feet of roof going into 12 feet of gutter. That's going to be a problem no matter what you do in most circumstances. So in that case, I would recommend heat cables for that client. But in general, I find it to just be a very blunt instrument to use, and it's inelegant.
Gotcha. So can you tell the listeners what some viable strategies would be, from an energy savings standpoint?
Certainly. It goes back to the 5 priorities I said: air seal 3 times and then add insulation.
Okay.
Generally, it's very simple. What melts snow?
Okay.
And that's the question for you. So it's the heat. So if you stop the heat, you stop the melting and you stop the ice damming.
Gotcha. So essentially what we want is a cold attic, not a warm attic.
Correct.
Okay, good. All right. Can you describe, or what is your definition of air sealing?
You know what? I haven't had anybody ask that question just like that. But what it is it's looking for any holes in the house, and typically they're quite small. The total leakage of a house may only be a couple square feet of leakage, so it's the equivalent of having, say, one window open 6 or 12 inches, something along those lines. So it's a bunch of small leaks generally. So you want to find the biggest leaks that you can first. Typically, those are going to be in the attic around, say, plumbing stacks, chimneys, light fixtures, things like that. And you want to seal those holes in a way that is not going to cause other issues. Say, recessed lights, you have to be very careful how you air seal them if they maintain an incandescent bulb, or else there's a fire hazard. And the same thing goes for sealing around chimneys. You want to be cautious how you do that.
Okay, what about, it's not unusual to have, I would say, intentional holes in the attic, to allow the attic to cool during the summer. They've got, so essentially the leaks in the attic are okay, provided that there's no heat getting into the attic?
Well, actually, I'm glad you asked that question, because there's actually 2 separate issues that I'm talking about here. So the attic is one space if you're talking a vented attic. So the attic is supposed to be outdoors in essence.
Okay.
Where air sealing is sealing the indoors of the house from the outside, where attic ventilation is much more about letting air from the outside into the attic so that the attic temperature is as close to outdoor temperature as possible.
Gotcha. And which do you prefer if you have your choice? Would you rather have a cold attic, or would you rather have the attic as finished space? storage space, something like that, not necessarily living space?
That is usually not my decision. That comes down to what the client needs and what the budget is.
Okay.
I do find it simpler to seal when you spray foam the roof deck, but that isn't always the appropriate action for a given house.
Gotcha. Okay, so I guess at this point, what I want to do is shift gears a little bit. And in your writing, you've used the terminology energy use intensity, EUI. Can you tell the audience what that is?
Certainly. So what it essentially is a miles per gallon for houses, and it is agnostic of fuel. So you can have an energy use intensity, or EUI, for a home that has whatever fuel. So it can be electricity and propane, or electricity and natural gas, or just electricity, or whatever the mixture might be, and you can rank them all against each other. And what my viewpoint is currently there's really no way to understand the efficiency of a home. And when you have an efficient home, typically there's other benefits that come with it. So if you have a house that doesn't have a great deal of air leakage, it probably has a lot fewer moisture problems. So the roof is likely to last longer, or the siding is likely to last longer. You're going to have more than likely fewer durability problems. And also, when you look at the cost of the energy, it's not necessarily going to be substantial, but say it's $50 a month difference from one comparable home to another when you're going to buy a house. That could easily add up to between $5,000 and $15,000 in value for that house. So the more efficient home should technically be worth more because it costs less to operate. The problem is right now there is no transparency to that subject. So you can find out what the taxes on a house are or what the insurance for a house is, but it's very, very difficult to understand how much energy it uses and what that costs and what that might change as far as overall operation costs for that home. So it's a big piece of the market that has yet to be unlocked that could actually unlock $1 to $2 trillion.
And how so? How would that happen? Or how would you see that happening?
Well, say every efficient home was worth $10,000 more, and there's approximately 100 million existing homes in the U.S., that's $1 trillion.
And I guess if I had a choice, if there was transparency in energy and I had a choice of buying one home versus another, the cost of high home performance, would be a valuable consideration, because I think it's something that really is not in the equation now that could be in the equation and would make a difference. So I think I agree with you. I've got a couple of text questions that have come in. Nate, what's your opinion of the new ASHRAE ventilation rate?
62.2?
I think so, yeah.
Okay. So that's the residential side. I don't do much commercial work, which is 62.1, so I'm not as familiar with it. The 62.2, I'm of similar opinion to Joe Stebrick, that it's probably a bit on the heavy side. So as I design ventilation for my clients, I try to do, as Joe Stebrick talks about, and provide variable amounts of airflow between 50 and 150% of 62.2 requirement, and set the thing so it's always on low, but give the clients an easy way to turn it up when they feel that they would like some more fresh air in the house.
Okay. All right. What I think we're going to do is I want to go to halftime now, and we'll thank our sponsors. It only takes about 90 seconds or so, and then we'll come back and we'll have a longer second half, because we have a lot of really fertile ground that we have to plow and go over. So, John, let's go to halftime.
And thanks to our association sponsors, the Indoor Air Quality Association, a nonprofit multidisciplinary organization dedicated to promoting the exchange of indoor environmental information through education and research. Visit them at IAQA.org.
The Restoration and Specialty Cleaners Association, who have been serving the needs of and advocating for their members for over 30 years. Remember, Triska is your link to industry training, certification, standards, and events. Their website is trsca.org. Thanks to our advertisers.
Gray Wolf Sensing Solutions, who use advanced sensor technology and embedded computers to provide superior environmental test instrumentation. Visit them at wolfsense.com.
Legends Environmental Insurance Services, the experts in insurance for environmental consultants and contractors for over 20 years. Visit them at legends-enviro.com, and, of course, our marquee sponsors. John Don Products, where restoration and abatement contractors shop. Visit them at their website, jondon.com. That's jondon.com.
CleanFacts, the #1 information source for cleaning and restoration professionals. Check them out at cleanfacts.com.
IAQ.net and Healthy Indoors Magazine, a free online digital magazine for industry professionals and consumers. Subscriptions are available at IAQ.net.
And Particles Plus. They are engineers and manufacturers of feature-rich particle counters, air quality monitoring instrumentation, and vacuum pump technology. ParticlesPlus.com. Count on us.
Please be sure to thank our sponsors for their support of IAQ Radio when you inquire about their services and products. Okay. Well, thanks, everybody, for hanging on, and let's move on with the second half of our show. Bill, back to you. I've got another equipment question. Let's say I just became a certified indoor environmentalist. I want to begin inspecting homes and buildings that have indoor environmental quality complaints. What would the basic equipment be that I would need? And if you can take the listeners through the cost of the equipment as well as what each piece would do, I would appreciate it.
Well, thank you. I think it'd be important, and I don't have really in front of me what the requirements are for a certified indoor environmental evaluator. That term's not quite familiar with me. So I would say you kind of go back to whatever that requires you to do. But I can make an educated guess that some of the basic parameters for indoor air quality are going to be temperature and humidity, air temperature and air humidity, and then looking for things like surface temperatures that can drop below the dew point. And when surface temperatures drop below the dew point, they can be a point of condensation for moisture that's in the air. And that can happen in even what I call small microclimates, like in a closet. We had an issue once in our own home with a garment bag that was close to a cold wall, and just the relative humidity in the house caused that to develop a little microclimate where humidity was trapped and condensed against the vinyl bag, causing development of some mold on the surface. So there's temperature, humidity, and then surface temperatures. And then the kind of gear you would need for that would be a good quality temperature and humidity meter, and very good quality ones are available. I would say you'd want to spend at least $75 to $100 to get a good one that's got a reliable range. There are much less expensive ones available, but as a professional, I don't think you should be using those. For surface temperatures, the best way is really use a spot IR thermometer or an infrared gun, sometimes they're called, and they just kind of assess over a bulk area the surface temperatures if you know how to use them correctly with emissivities and that kind of thing. You could also use a thermal imager, and there's some thermal imagers actually coming out that are hybridized with temperature humidity meters and then also contact and non-contact moisture meters. So you can see we're sort of hovering around the issue of water. And I think you'll find in a lot of the literature, a lot of the publication, Nate's sitting here nodding his head to me, water is a big issue. It's the control of water, having it flow around or through the structure in controlled manners and not allowing it to accumulate in different places. But
you know, in terms of let's go over some of the moisture meter options that would be available. I guess you have some that might be considered non-destructive. You would have some that would penetrate Any particular ones that you like or recommend?
I like the hybrid ones that actually do non-contact as well as contact, because the non-contact ones, you do have to, you realize that they're sensing for the presence of moisture in the material by using a radio wave that's moving through the material, and there's only so much surface material they can penetrate through. Whereas a contact one, you actually use pin probes, penetrate the material, and then measure capacitance between 2 points of the material and look for variation on different scales for building materials and woods and things like that. So it's nice to have the dual prong approach of both contact and non-contact. And again, with the way electronics are going, in measurement electronics too, these prices are coming way down, well below $300. You can acquire an instrument that would do temperature, humidity, and contact and non-contact moisture.
Gotcha. Let's talk a little bit about, I guess, the range of thermal cameras. And you mentioned that you have some that get attached to to attach to an iPhone type application. But would that be sufficient, you think, or do you think you need something better than that?
Well, I think it depends on what your goal is with the thermal image. If you want to give actual measured temperatures, get measurements from the device, then I would say you should really stick to a high resolution, high accuracy type thermal imager. And usually these are for people doing forensic analysis or things where there's a lot of money on the line. If you're looking to see relative temperature differences, that's where the lower cost ones can come into play. And what I consider a thermal imager is sort of a bulk assessment tool. You can walk into a room or a house and start taking a look at it thermally, and then patterns will start to jump out and say, there's something it'll say to you, there's something going on in this particular area, this particular zone, that you should take a more in-depth look at, either with temperature and humidity meters, surface contact meters, or moisture meters. So I think there's different purposes for these tools, and I think in kind of our realm of home performance industry, you could be well under $2,500, between $250 and $2,500, and have a really good thermal imager that you know how to use and know how to interpret the readings from to make your work more productive.
Right. Well, let's I think some of the things that indoor environmental inspectors commonly find, besides water, particulate. I think they would be concerned about particulate. So, tell us a little bit about a particle counter, how they work, and what the price range might be for particle counters, and where what sort of data would be important to a property owner.
For particle counters, because particles can come in a variety of size ranges, they usually operate within certain ranges of microns to tell you what the size of the particle is. These would be the more advanced meters, and this would be ones that could be used for more in-depth diagnostics to look at what the sources are. If it's things like pet dander, if it's tobacco smoke, if it's other particles that are caused, say, even by cooking and things like that. The ability for it to report the range of size is important, especially when you get down to looking at the health impact of various sizes. And it's the 2.5 micron particles that are considered most damaging because they can bypass most of the body's natural filtration systems and lodge themselves deep into your lung sacs, which actually cause is a real statistical correlation between low, tiny particulate exposure and health impact. So if you're trying to control the small particles, you're going to need to have a meter that measures those small particles. And you're probably looking at the range of between upwards of $2,000 to $5,000 to get a good particulate meter, and perhaps even more than that. I know you and Joe use some real high-tech products for that kind of research and work.
Let's talk a little bit about gases. Gases could be an issue in homes. It could be carbon monoxide. It could be a variety of different types of VOCs. Do you have anything that an inspector could use for that type of analysis and sample?
Sure. The most common one we talk about is carbon monoxide because it's so pervasive. It comes from local sources of combustion, usually trying to burn something and convert thermal energy that's trapped in the fuel into work energy or heat. So it could be small appliances, it could be small engines, it could be cooking, and of course appliances such as furnaces and water heaters. These all can, if the combustion is not happening correctly, carbon monoxide could be generated, and then if the venting is not happening correctly, it can cause the carbon monoxide to leak back into the structure. And carbon monoxide is a silent poison called silent killer. There's no way for a human really to detect it except by feeling sick from it. That's not a very good way of detecting anything. So the carbon monoxide, there's a lot of screening levels, if you will. There are standard carbon monoxide alarms, which usually have the UL 2034 label on them. And those alarms are, when those go off, it's an immediate situation, the way those are gauged in terms of alarm limits and levels. When those go off, you need to take an immediate response. There are other low-level alarms which are available from a few sources, and those alarms give you a lot earlier warning and tell you about lower levels that may be present over longer periods of time. And there's good reasons for having both we call a high-level and a low-level alarm present. And then the auditor themselves can come in with an ambient carbon monoxide monitor that they can use to screen to see if, what the differences are between the outdoor air and the indoor air in any particular sources. And if you get into measuring carbon monoxide inside the combustion gas stream, the flue gas stream, then you have to take an additional measure and use a different type of meter that has more filters so it can extract that carbon monoxide signal out of the flue gas, which is a little bit more complicated than getting it out of the ambient level.
When or why would that be done? Can you provide an example?
Sure. A flue gas test.
Right.
It would be done to determine how the appliance is running. Is it conforming with standards? And we talked a little bit before about BPI standards. There's a new Building Performance Institute, BPI.org. They have a new national standard, ANSI standard called BPI 1200, which talks about how home performance testing should be done. And they actually lay out the groundwork for different levels for programs or structures that are going to comply with that standard. So basically, either a contractor would do it for their awareness and the health and safety of their customer, or you would do it in the conformance with a standard if you're doing energy auditing, weatherization work that was compliant with BPI 1200.
Thanks. All right, let's change topics. Nate, you recently wrote a blog on low-cost home indoor air quality monitors. Number one, what inspired you to write a blog on that, and what types of monitors did you compare, and what were the results?
It's a great question. So indoor air quality is part of the health side of what I do. And until now, there really haven't been any monitors for any reasonable cost to be able to find out if there is a problem in a client home. So basically, it's all these invisible problems, and there wasn't an inexpensive way to make them visible. And last year, I started watching several of these products coming, and a lot of them were originally developed in Asia, like particularly China and India have just horrific outdoor air quality problems, huge levels of particulates in the air, enough so that it's actually unsafe to exercise, and they have apps just for doing this sort of thing. And those devices are starting to filter their way to the U.S., because while we don't necessarily realize it, a fair number of places in the U.S. have outdoor air quality problems, particularly California and the Rust Belt, and then sometimes in the South in the summertime. And so I wanted to figure out which one of these monitors, if any, was actually worthwhile to recommend to clients. So I set out and started buying a number of them, and then I was given some of them, and then I was lent several of them, and I started to compare them against each other. One of the problems with these, which you alluded to, is that they all measure something slightly different. So they all have different sensors. So it's like comparing an apple, an orange, and a banana. Yes, they're all fruits, but beyond that, it can be somewhat difficult. So I did my best over about 6 months here to watch what they did in various events in the house. So like I have burnt some things horribly in the kitchen, which will set off the particulate monitor very quickly. And then I noted roost cleaners tended to set off the VOC alerts, the volatile organic compound sensors. And I just started to pay attention to which ones I liked, which ones I didn't like, and the same framework that I talked about earlier, where you need to have awareness first, and then understanding, and then action. I wanted to find out which ones were most likely to not only let a homeowner know that there was a problem, but also help them in finding a solution. And not many of them did that well going through that gauntlet.
Joe has one at home. We interviewed a group from Carnegie Mellon, I guess a spinoff, that had developed a device. I just wondered whether or not you had tested that one.
Yes, that's the spec. And
right.
So they sent me one. And then also I was just in the 8th cohort for Linda Wigington's low-cost particulate meter study. Actually, I'm returning the devices today. They're in my car as we speak. And I liked the device to some extent, but I found that it didn't have good alerts for homeowners to help them understand what, or like when there's a particulate spike. So one thing I like about Foobot is when there's a particulate spike, you will get a notification on your phone. In fact, you get so many notifications that after a while you turn them off. But at least it begins to help cue you in on when pollution events are happening. And that was something that I didn't see happen in spec. And spec doesn't have a VOC monitor, which is another thing that I'm interested in, although I've heard they're working on developing that. So I like the device, but I didn't like it quite as well as some of the other devices.
Gotcha. What sort of feedback have you had on the blog?
At first it was negative, and it was really kind of a bummer because I had hundreds of dollars and hundreds of hours of work to create that article. But that happens sometimes. Everybody's a critic. And then over time, a number of people have come in and said very nice things about it. One fellow said that this is really the only article on these devices that's worth reading. And I don't think a whole lot of people have really tried to look at these devices from a professional perspective and also comparing them directly. The idea that I had in mind in writing this article was much more like a Consumer Reports comparison, or I've always been reading car magazines since I was 10 years old, and I love the comparison articles that they do there. So that was what I had in mind.
Well, Bill, do you sell any of this type of equipment?
Yeah, we do. We sell some of the professional grade particulate monitors, CO monitors, things like that. And we're building a segment on our website called For the Home. And the intention is it will be low-cost monitors for contractors like me who may wish to purchase them and use them with his clients or recommend them to his clients. So it'll be both for contractors, technicians, and consumers. So we have agreements set up. We just don't have all the products listed yet. It should be in the next month. We'll have the Foobot. We'll have the spec. We'll also have a low-cost radon monitor. And we have low-level CO alarms, which we consider sort of in that grouping of smart products for interested consumers who care about their IAQ, as well as the contractors.
Right. Did you read Nate's blog?
Absolutely, I did, and I threw back maybe the second comment, and it might have sounded a little negative, but the kind of the caution flag I threw up was I want to make sure people understand when they use these, they are not equivalent to those higher end devices that a contractor or a professional may use. But I do, and this is also talking with the developer of the Foobot, and kind of had to wrestle in my own mind. What is the purpose for these products? Where do they really stand? How do they fit into the ecosystem? And I sort of consider them like a half step to a full diagnostic. And in the words of the Jacques from Foobot, it's like it indicates trends. These are not exact perfect measurements, but these are trends of things going on. And in much the same sense that a low-cost thermal imager could lead you to deeper investigation in a certain area of a house, a low-cost IAQ monitor could lead you to deeper investigation of an IAQ complaint. And the other thing I look at, like it's a good idea for contractors to use these, building performance, energy contractors, HVAC contractors, because somebody may have a complaint, a customer may have a complaint, and you've got no information to go on. It could be a myriad of problems. Now, with one of these low-cost monitors, you have a little bit more clear of a picture, a little clearer picture of what's going on. Not sharply in focus. It's not binoculars. It's not a microscope to give you the exact information, but it's going to allow you to focus in on a few more details and actually make your work more effective and your procedures more proactive.
I think that's going to be a growing part of your business. It would seem to me that, someone in indoor air quality investigation from time to time is going to run into a situation where they need, where they need a piece of equipment that may be pretty sophisticated, may be costly. Does your company do rentals?
No, we haven't gotten into rentals on that yet. There's usually what happens is actually the cost of equipment is coming down so much that the cost of a rental, usually you rent it for 3 or 4 weeks at a decent rental rate that makes sense for us, and you've pretty much bought the product. So
gotcha.
We find when we share rental rates with people that are sort of like market rates, unless they just need them for a day, they usually end up figuring out a way to finance, and we do provide some financing solutions to third parties.
Gotcha. I guess some of these pieces of equipment might be utilized together. Like when you're doing a blower door, would someone perhaps utilize thermal imaging camera at the same time? Would that help?
Yeah, that's Nate saying, whispering over my shoulder here, Batman and Robin. They really do go together. It's a dynamic duo. The blower door test puts a pressure difference, sort of like a pressure stress on the house. And if you catch it at the right time of the day, and this is where your training and knowledge and experience comes in, where you have enough temperature, thermal differential between the outside and inside, and perhaps you haven't quite got all the thermal solar radiation from the day's heat coming at your house, you can actually draw in warmer or colder air such that you make it show up thermally on the inside, and then you just take a thermal walk around the structure and take pictures as you go with the thermal imager. I've had 2 comprehensive energy audits and remediations done on 2 houses in the last 5 years. I use the same guy who's a really skilled guy, local guy actually from Irwin, Pennsylvania, and he did the same process, and we found lickety split, found those problem areas very quickly with the blower door and thermal imager together.
What did it cost you to have it done?
It was about $5,000 for the first house, which included both the audit and the repair work.
Okay.
And of course, just like anything, it's kind of like Nate mentioned, like medicine. Similar people may have similar symptoms, but have very different treatments. So, your results may vary. Second one, I went a little deeper, and we did $7,500 worth of work. The audit itself stood at around $450, a comprehensive audit, and some reporting, photographs, also some software that the energy doctor, the guy I work with, ran through, enabling us to appeal to my techie side with numbers.
Well, I mean, the primary reason you did it was, I guess, you had substantial energy savings. You made the investment, but how long was your payback?
Actually, I did it for comfort.
Okay.
I didn't do it for energy. I knew energy was sitting there in the background, and it made total scientific sense to me, but I did it for comfort. There were thermal gradients between levels in the house. Different rooms had problems. We did on one of the houses, we did have some ice damming and a gutter ripped off. So it was about comfort, mechanical issues, and energy was sitting there the whole time. Payback period, the calculations were running around 5 years, I think, for both of the structures. And that actually, having the information from the payback period in the software help us make decisions as to how far and how deep to go.
Gotcha.
So it allows us to say, okay, yes, let's do, usually when you're working with existing structures, a home performance or energy auditor will present you with a menu of solutions and then some payback periods, as well as things that it's going to address, like this is going to be your main comfort influencer, or this will be your main energy influencer. And you take a look at all those and you make an informed decision as the homeowner as to what you're going to do. So I really enjoyed participating in the process to kind of see the output of the work from the tools that I sell.
In addition to selling the tools, I suspect that your company gets involved in training. What types of training programs do you get involved in with something like, for instance, blower doors or, the infrared cameras and so on and so forth?
We do a lot of training at trade shows and seminars, things like that, where we get in front of a class. We also do some training on our website via videos, as well as downloads and informative guides that are training materials. And then we also do webinars, live ones, and then we record them and archive them to provide training. We always try to respect who the expert is, and we have certain core expertise in our company because of our experience and background. But a lot of times, some of that core expertise, we will draw in subject matter experts from different areas of our industry and into our network, and we've been able to develop that such that we can pull in their help. And a lot of the manufacturers have really great people on staff that are way in depth knowledge beyond where we are. We're really good at airflow, combustion, and air conditioning. But the blower doors, we leave to the blower door companies. They have some really in-depth trainers there.
Right. Looking at all the products that you sell, is there a growth side? If you do an analysis on all the different devices that you sell, is one of them showing a growth pattern?
I think the strongest growth pattern we have, and it's not entirely related to home performance. It is really. It's in the air conditioning test products. The traditional ones have been analog gauges to monitor pressures and then temperature meters and a lot of sidebar calculations the technician has to do. And the strong current has been the last decade and has really accelerated to devices that measure these air conditioning parameters digitally and allow you to do a lot of comprehensive troubleshooting. And there's some even that one in particular called iManifold that uses an app that's actually a free app. You can put all the info in from any device you have, or you can tie it into the product that we sell that will automatically stream it into it. But the amount of troubleshooting information there is just really terrific, and I see that as the big trend. Those trends are also being followed in the blower door companies, Retrofit and the Energy Conservatory. They're both moving to more advanced communicative cloud-based systems that do a lot of data exchange and provide you with more higher enhancement of the data, putting more data in your hands.
Okay. All right. Well, we're probably going to move now into what we call our roundup. And what we like to do in the roundup is we like to give our guests the last word. First of all, is there any final comment? Is there anything that that you'd like to add? And I'd like you to also each provide your contact information so the listeners can get in touch with you. So, Bill, if you want to go first, anything I forgot to ask, any final comments, give you a minute or so to do that.
Okay. Thank you, Cliff. I think the main comment is don't overextend your reach. Be sure to ask questions and understand the diagnostic tools you're using. And then some processes and procedures actually have hazards associated with them. And if you're not aware of those, you could be imperiling yourself or your client. So make sure you do get good training. It's a good ratio to spend probably about 20% of your tool budget on getting trained on your tools, maybe 25%. There's great training classes out there. In fact, even ones run by the fellows that are presenting this program here, Joe and Cliff. So my contact information is bill@TruTechTools.com. That's TruTechTools.com. And that's probably the best way to reach me. And if you want to subscribe to our newsletter or see our free webinars or anything like that, just drop me a line and I'll direct you in the right area.
Okay. Nate, let's switch over to you.
Okay, well, thanks. And I'd actually like to go back to the subject you mentioned earlier, or asked about earlier, the EUI, the energy use intensity. Why I have been talking about that so much is if you think about the value of one of these home performance projects, if you sold your house a year after you did, say, a $5,000 to $20,000 project, what percentage of that do you think you would get back? And in most parts of the country, I would argue that if you got 10 or 20% of it, you'd be doing very, very well. And that's a problem. So we talk about like new cars being a horrible investment because as soon as the tires touch the pavement, the value goes from $20,000 to $17,000 as it switches from retail to wholesale. If you have a $15,000 project and a year later it's worth $0 to $1,000, that is not a good way to be honest with a homeowner or to get actual work done. So that's why I'm focusing so much on this EUI thing, because I want to start having the efficiency of homes become part of their value so that even if you don't get all of the money back from a project, you might get half or a third or 3/4 or something like that. And at that point, we're much more likely to unlock this market, which for literally my entire lifetime has been essentially dead in the water.
I didn't realize Radio Joe was on. Let's bring him in because he may have some final questions or comments.
I just want to thank both of you for joining us. It's I'm sorry I got in a little late teaching up in Somerset here. So that energy use was an EUI, Nate.
Yes.
Who's developing that?
It's actually just a number. All you need are fuel usages for the year, electricity, natural gas, whatever, and the square footage of the house. And it's just a ratio of number of 1,000 BTUs per square foot per year that are used by a house. It's not a perfect metric in some ways, but in my view, it's basically the best single metric. If you have to have one, that's the one that I want. And the Department of Energy has been using it for some time. And they actually have a building performance database that has thousands of homes in every state that you can compare what a house is versus, like what a client home is versus the houses in the building performance database. So it's a metric that's well known and already pretty well adopted. So I'm just trying to move it forward a little bit.
Okay, getting the word out. And that would help get that return on investment, I guess, if you could compare your home to other homes and be able to show that, when a new buyer purchases it, they're going to have a lower energy bill, I guess.
Yes, which can increase the value of the home. Now, it's return on investment. I always like to kind of run the other direction from. because then you have to define what do you want. Do you want a 3-year payback or a 10-year payback or whatever? And the projects that I specialize in Cleveland generally have paybacks anywhere between 20 and 150 years. So payback is not why people are doing these.
And I guess one final question for Bill. Bill, where do you see the whole energy industry going? I mean, is it going the direction of Nate, or are the guys trying to branch into other things? Because as I understand it, it's tougher and tougher with the utility programs being the main area people get their work from. Where are they going to find their work in the future once these utility programs start to slow down?
Yeah, I think it's going to come from indoor air quality. I think that's the perfect overlay of investigation that can be provided for residential, and it really does tie to the building dynamics. It ties to what pollutants are inside the home, ones that get in, ones that get out, and water management sources like carbon monoxide. So if you really step back and think about it, the list on the IAQ side and the list on the home performance side isn't really that far apart, and it's a very logical next step for the home performance industry to be part of the IAQ diagnostic, not to replace the full certified individual, but to, again, be that half step, be aware and cognizant of taking the right steps along with the right training.
Well, thanks, guys. We appreciate you joining us. And Cliff, thanks for bringing me in here at the last minute. I'm going to head back to class, but thanks for covering for me this week.
No problem. It was a pleasure. Okay. Well, before we leave, we want to thank today's guests, Bill Spohn, Nate Adams, my co-host, Radio Joe Hughes, our engineer, John, You Gotta Have Faith, and most importantly, we want to thank you, our growing audience of loyal listeners. Please come back and join us next Friday at noon for the next broadcast of IAQ Radio.
This has been another IAQ Radio production.